So in the case of nerve impulse propagation, we have to first understand what do you mean by impulse propagation. Impulse propagation basically means transmission of messages in a neuron. If there are 10 neurons or if there are 1000 neurons, the message will be transmitted from one neuron to second neuron to third neuron up to 1000 neuron. This transmission of messages is known by the name nerve impulse propagation. Now if you take a nerve impulse propagation, we can find four basic stages are there. First we have to understand what is the meaning of these four terms like membrane potential, depolarization, action potential and repolarization. To begin with, we will start with the term membrane potential. Now in the case of a normal neuron, if we can find this is a normal neuron is shown here, and what is shown is the electrical charge on of the normal neuron. Usually the outer side of a neuron will be positively charged and inner side will be negatively charged, and that means there will be an overall charge of minus 70 millivolt. So this charge is what we call a resting potential. That is, when a neuron is not transmitting any messages or not doing much work, it will be still having an electrical charge or an electrical potential, and that is known by the name resting potential. So the potential charge of a neuron when neuron is in a resting stage. What is a resting stage? The neuron is not conducting any message transmission. That situation is a resting stage, and in a resting neuron this will be the overall charge of a resting neuron, that is minus 70 millivolt. What is a millivolt? 1 by 1000 of a volt is a millivolt. So when a neuron is in a resting state, the number of sodium ions on the ions outside the neuron is more compared with the number of potassium ions. So here there is a sentence, there are two types of ions, one is sodium ion and second one is the potassium ion. And what he is saying here is that the number of sodium ion will be more than the number of potassium ion. And there is a charge for sodium ion as well as potassium ion. So the outside it is sodium ion. Sodium ions are normally positively charged, whereas potassium ions are negatively charged. So there is more number of sodium ions on the inner side, on the outer side, but there is not. If that means there are 100 sodium ions on the outer side, there are less of potassium ions on the inner side. So if you are comparing the charge between outer side and inner side, we can see that outer side has more positive charge because of more number of sodium ions, whereas inner side has less potassium ions, and because of this there is a charge difference of minus 70 millivolt. So that is what we mean by the name membrane potential. So that is when a number of potassium ions in the exoplasm is more than number of sodium ions. Now if you when a neuron is in a resting stage, the sodium ions on the outside is more compared with the potassium ions. So there is more positive charge on the outer side. Here what is shown here is that here there will be more positive charged sodium ions. Since their number is more, here it is positively charged. Now whereas in the case of inside, that is on the inner side of the cytoplasm, otherwise known by the name exoplasm, the number of negatively charged potassium ions are more. See, the number of potassium ions in the cytoplasm or in the exoplasm is more than number of sodium ions. Since potassium ions are negatively charged, there is a overall negative charge here. So that is why inner side is negatively charged, outer side is positively charged. Now in the exoplasm, in addition to these ions, there are many negatively charged impermeable proteins. So why this, how this minus 17 negative charge is there? Here there is if there are 10 positive charged sodium ions here, An equal number of negatively charged potassium ions will be there, and overall charge will be therefore equal. But here there is an excess of negative charge, and that excess of negative charge is actually coming because of the presence of many negatively charged proteins. And these negatively charged proteins are present in the cytoplasm or in the exoplasm. So what I am telling is that if there are 10 sodium ions here, there will be a positive charge here. And if there are 10 potassium ions here, there will be negative charge. So this 10 positive charge and this 10 negative charge will be cancelling each other. But still there is an excess of negative charge. How that excess of minus 70 negative charge is coming? That is because of the presence of certain negatively charged proteins here. And this negatively charged proteins is giving the exoplasm a minus 70 negative charge. And that minus 70 negative charge is what we mean by the name membrane potential, otherwise known by the name resting potential. Now in the resting stage of the neuron, the sodium ions move out of the exoplasm, whereas the potassium ions will be move out from outside into the exoplasm. So normally there is a pump is operating. If there is any sodium ions are here, these sodium ions will be pumped from inside to outside. Similarly, if there are any negatively charged potassium ions are present on the outside of the membrane, that will be pumped into the cytoplasm or into exoplasm. And for that there is a pump. This pump is known as sodium potassium pump. So the function of the sodium potassium ion pump is to pump the sodium ion from the exoplasm to the outside. And the second function it is doing is that it will be pumping sodium ions, which are potassium ions, which are present on the outside the membrane into the exoplasm. So two events are taking place. One is that if there is any negatively charged potassium ion this side, that will be pumped into the cytoplasm. Similarly, if there is any positively charged sodium ions are here, that will be pumped outside. And that pumping mechanism is actually conducted by a pump known by the name sodium potassium. It is basically a protein structure itself. So this is how normally the membrane potential is maintained by a neuronal network, and that is known by the name resting potential, otherwise known by the name membrane potential. Now we have to see how this membrane potential is changing. That situation is known by the name depolarization. For example, whenever a stimulus is touching a neuron, some kind of stimulus or some kind of activity or some kind of touch is occurring to a neuron, sodium ions move into the exoplasm. Normally the sodium ions are present on the outer side. When there is some kind of stimulus, these sodium ions will be moving from outside to the exoplasm. That is what they are saying. Sodium ions move into the exoplasm. Here you can see that. So when there is some kind of impulse, at the site of the impulse, an equal number of some amount of sodium ions will be moving into the cytoplasm. Normally, what is the normal charge here is minus 70. Now what happens is that when 70 sodium ions enter into the exoplasm, the potentiality becomes 0 millivolt. That you have to understand. See, this is the first situation. What is the charge here? Minus 70. That minus 70 negative charge is coming because of the presence of some extra negatively charged protein. Now an impulse is taking place here, and because of that impulse, 70 positively charged sodium ions will be moving from outside into the cytoplasm or into the exoplasm. So here there is an overall minus 70 millivolt of negative charge. When 70 positively charged ions are entering into that, this minus 70 and plus 70 will be cancelling each other, producing an overall charge of 0 millivolt. And that situation is what we mean by depolarization. So during a depolarization, what happens? A stimulus is occurring. As a result of stimulus, 70 sodium ions will be moving into the exoplasm, and because of the movement of 70 positively charged ions into the exoplasm, the overall charge becomes zero. When that situation is happening, we call it by the name depolarization. So that is the second event, depolarization. Then depolarization means the resting for the electrical charge of a resting potential is minus 70. When as a result of stimulus, the minus 70 negative charge becomes 0 milliwatt. Then it is known as a depolarization. Depolarization occurs only when some kind of stimulus is occurring. And this explains the potentiality of exoplasm when inner impulse is passing through a neuron. So movement of sodium ions flowing from outside into the exoplasm continues until plus 30 millivolt is reached. So what is the meaning of that? So here there is a negative charge of minus 70. When 70 positive charged sodium ions are entering, the charge becomes 0. But instead of 70, normally 100 sodium ions are entering into that. So when 100 sodium ions are entering, here only minus 70 negative charge. Minus 70 and minus 70 will be still cancelling each other. But when extra 30 ions are entering, the overall charge inside the membrane, inside the cytoplasm will become plus 30 milliwatt. And that is known by the name action potential. So what happens when action potential develops? When only 70 sodium ions are entering, the charge is only 0. When extra 30 ions are entering, the charge becomes positive, plus 30 millivolt. So that plus 30 millivolt is what we call by the name action potential. So that is the third event in the case of a nerve impulse propagation. One is depolarization. What is depolarization? Simply the charge getting neutralized. That event is known by the name depolarization. When extra plus 30, extra 30, so positively charged sodium ions are entering, the overall charge becomes plus 30, and that situation is known by the name action potential. So one action potential is taking place here. This will be transmitted to next segment. So in the first case, the membrane potential, then there is depolarization, then there is action potential of plus 30. Now fourth event is known by the name repolarization. Now during repolarization, what happens? It explains the alteration. Alteration means change of action potentiality to membrane potentiality. That is what is action potential plus 30. When plus 30 is changing back to minus 70 again, we call that event as the repolarization. How this plus 30 has been taken place? Because of the entry of 100 positively charged sodium ions. When 100 sodium positively charged sodium ions are moving out again, this plus 30 becomes minus 70. And that is how this is how the overall negative charge is again returned to its normal level, that is minus 70. So when 100 sodium ions are entering here, the charge becomes 30, positive plus 30. When 100 sodium ions are moving out again, the charge becomes minus 70 again, and that event is known by the name repolarization. So if you take a nerve impulse propagation, you have to remember, you have to draw this diagram, then you have to keep explaining. If you remember the idea of this diagram, it will be easy for you to explain what is membrane potential. In a membrane potential, outside is positive charged, inside is negative charged. Why outside is positive charged? Because there are more sodium ions. Why inside is negatively charged? Because there are more number of potassium ions. So potassium ions are negatively charged. And during an impulse, 100 sodium ions will be entering into the first 70 sodium ions will be entering into the cytoplasm, then charge becomes 0. When another 30 sodium ions are entering again, the overall charge becomes positive, that is plus 30. And that situation is what we mean by the name action potential. Now after this event of action potential, after some time the neuron will be going back to its normal state again, and during that process 100 sodium ions will be moving out from the exoplasm, and that situation is known by the name repolarization. So these are the four basic events in the case of a repolarization, and this is how you have to explain the different steps which are involved in a membrane and a potentiality. So this is an important question also. So most of the time you can expect a question based on give an account of the impulse transmission or membrane transmission of impulse. So different way it can be coming, or they will ask you what do you mean by resting potential, or they will ask you what is action potential. So if you remember this picture, this diagram is in your mind. If you know, draw this diagram many times at home and try to think about it, how this charge difference is coming. Then try to explain it in your own words so that it will be easier for you. Otherwise, this whole idea will become very confusing. Now, there is another idea, that is all or none law. According to the all or none law, there is a minimum amount of stimulus is required for nerve impulse transmission. Only if this minimum amount, minimum intensity is there, the impulse transmission will be taking place. That minimum intensity is known as threshold stimulus. And if the intensity of the stimulus is below the threshold, there will not be any production of any action potential. So in order to develop an action potential, the stimulus is of a certain particular intensity. If it is below that particular intensity, there will not be any action potential, and that is known by the name threshold. And this law that explains either the stimulus is taking, either the action potential is taking place completely, or it won't be taking place, or no action potential is taking place. That law is known by the name all or none law. Then what is expected from your syllabus again is